The first humans did not invent heating because they wanted comfort. They invented it because the cold was trying to kill them. Hundreds of thousands of years ago, long before cities, kingdoms, or written history, our ancestors faced freezing nights that could easily become their last. Thick animal skins helped, caves blocked the wind, but neither could replace the warmth of a fire. At some point, early humans learned not just to fear flames, but to control them. That single breakthrough changed the future of our species forever. Archaeological evidence suggests that controlled fire was being used by ancient human ancestors at least 400,000 years ago, and possibly much earlier. A glowing campfire became more than a source of warmth. It frightened away predators, allowed people to cook food, extend daylight, and survive winters that would otherwise have been impossible. For the first time, humans could begin adapting to colder climates instead of fleeing them. As families gathered around open flames, the hearth became the center of daily life. Stories were told beside it. Tools were repaired beside it. Food was prepared over it. Entire communities were built around this simple source of heat. In many early homes, the fire never truly went out. Keeping it alive was as important as finding food. But these early heating systems came with serious problems. Smoke filled enclosed shelters, making breathing difficult and blackening walls and ceilings. Sparks regularly ignited roofs made from straw or wood. A fire provided warmth, but it also demanded constant attention. Too little fuel, and the family froze. Too much, and the home itself could burn. As civilizations emerged across Mesopotamia, Egypt, China, and Europe, builders searched for better ways to stay warm. Homes gradually became more sophisticated. Simple roof openings allowed smoke to escape. Fire pits became permanent hearths built from stone or clay. Yet for thousands of years, most people still lived only a few steps away from an open flame. Then, around the 1st century before Christ, one civilization took heating to an entirely different level. The Romans were famous for their roads, aqueducts, and engineering, but one of their most remarkable inventions remained hidden beneath the floor. It was called the hypocaust, a revolutionary heating system that worked by circulating hot air under stone floors and inside hollow walls. Furnaces outside the building produced hot gases that flowed through carefully designed spaces beneath rooms, gently warming the floors above. Walking into a Roman bathhouse during winter must have felt almost magical. While freezing air lingered outside, warm stone floors radiated comfortable heat throughout enormous public buildings. Wealthy villas adopted similar systems, turning luxury homes into some of the most comfortable residences the ancient world had ever seen. Yet even this incredible innovation had limitations. Hypocausts required enormous amounts of wood, constant maintenance, and skilled builders. They were expensive to construct, and even more expensive to operate. For ordinary families across the Roman Empire, the humble fireplace remained the only realistic source of warmth. The collapse of the Western Roman Empire did more than redraw the political map of Europe. It also marked the decline of one of history's most advanced heating technologies. As Roman engineering knowledge faded, the sophisticated hypocaust became increasingly rare. Most people once again relied on the same solution their distant ancestors had used for thousands of years: an open fire in the middle of the home. Life during the early Middle Ages was far colder than many people imagine. Peasant cottages were usually built from timber, mud, and thatch, with a single room serving as kitchen, bedroom, and living space. The central hearth burned almost constantly, filling the interior with thick smoke that escaped only through small holes in the roof or around loose thatch. Walls became coated with soot, eyes constantly watered, and breathing smoke was accepted as an unavoidable part of daily life. Even Europe's wealthiest nobles weren't much better off. Massive stone castles looked imposing from the outside, but inside they were often freezing. Thick stone walls absorbed cold during winter and retained it throughout the day. Great halls featured enormous fireplaces large enough for a person to stand inside, yet much of the heat disappeared straight up the chimney, or before chimneys became common, simply escaped through openings in the roof. Servants worked endlessly carrying firewood, while tapestries, heavy curtains, and thick rushes on the floor helped trap what little warmth remained. One of the most important improvements of the medieval period wasn't a bigger fire, it was learning how to control the smoke. Between the 11th and 13th centuries, chimneys became increasingly common across Europe. Instead of allowing smoke to drift through the room before escaping, chimneys directed it upward through specially constructed flues. This seemingly simple innovation transformed home design forever. With smoke safely vented outside, fireplaces could now be built against interior walls instead of occupying the center of the room. Homes could be divided into separate living spaces. Upper floors became more practical, and indoor air quality improved dramatically. Families no longer had to choose between warmth and breathable air. It was one of those quiet inventions that reshaped architecture without most people realizing it. But another problem was beginning to emerge. For centuries, wood had been the world's primary heating fuel. As Europe's population expanded, forests around growing towns disappeared at an alarming rate. Ships, homes, workshops, and furnaces all competed for the same timber. In many regions, firewood became increasingly scarce and expensive. The solution came from beneath the ground. Coal had been known since Roman times, but during the late Middle Ages and especially into the 16th and 17th centuries, it became an increasingly important source of heat. Unlike wood, coal burned hotter and lasted longer. Cities such as London embraced it out of necessity, importing enormous quantities from nearby mining regions. Coal solved one crisis but created another. Thick black smoke poured from homes, workshops, and bakeries, covering entire cities in soot. Visitors to London often described skies darkened by smoke even during daylight. The smell of burning coal became inseparable from urban life, while chimneys continuously released ash and pollutants into the air. People accepted the filthy atmosphere because the alternative was freezing. Still, coal unlocked possibilities that wood never could. Its greater energy density would soon fuel not only household fires, but also the machines that launched one of the greatest transformations in human history, the Industrial Revolution. Heating was no longer just about surviving winter. It was becoming part of a world powered by steam, iron, and innovation. By the 18th century, heating was about to change more rapidly than it had in the previous 1,000 years. The Industrial Revolution was transforming nearly every aspect of daily life, and the simple fireplace that had warmed generations was beginning to look outdated. One of the first major breakthroughs was the cast-iron stove. Unlike an open fireplace, a cast-iron stove trapped heat inside a sealed metal chamber before slowly releasing it into the room. Instead of losing most of its warmth up the chimney, it used fuel far more efficiently. Families burned less wood or coal while producing significantly more heat. Homes became warmer, fuel bills dropped, and kitchens became easier to manage throughout the harsh winter months. Inventors across Europe and North America quickly improved these designs. Adjustable vents allowed people to control airflow, making fires burn hotter or slower as needed. Flat cooking surfaces turned the stove into both a heater and a kitchen appliance. For millions of households, the cast-iron stove became the heart of the home, replacing the smoky open hearth that had dominated human history for centuries. Meanwhile, factories faced an entirely different challenge. Large industrial buildings could not be heated effectively by dozens of individual fireplaces. Engineers needed a way to distribute heat throughout entire structures. Their solution came from the same technology powering trains and machinery: steam. As boilers generated high-pressure steam to drive engines, engineers realized that the hot steam itself could also carry heat. Pipes transported steam through factories, warehouses, hospitals, and government buildings, warming large spaces far more evenly than scattered fireplaces ever could. Workers no longer crowded around a single fire. Entire rooms could now be heated from one central source. One of the pioneers behind this idea was American engineer Birdsell Holley. During the 19th century, Holley developed practical systems that distributed heated water and steam through networks of insulated pipes. His innovations laid the foundation for modern district heating, allowing entire neighborhoods to receive heat from a single central plant. What had once required dozens of separate fires could now be managed by one carefully controlled system. The next great innovation was both simple and brilliant: the radiator. Instead of relying on direct flames, hot water or steam traveled through metal radiators installed inside each room. As the hot metal warmed the surrounding air, heat spread naturally throughout the space. Rooms became more comfortable, temperatures more consistent, and homes far safer without exposed fires burning day and night. By the late 19th and early 20th centuries, central heating was becoming a symbol of modern living. Wealthy homes were among the first to install boiler systems hidden away in basements, where coal or later oil and gas heated water that circulated through pipes inside walls and floors. Occupants enjoyed warm bedrooms, dining rooms, and hallways without carrying firewood from room to room. Apartment buildings, schools, hotels, and office buildings soon adopted similar systems. Architects no longer had to design every room around a fireplace. Freed from that limitation, buildings grew taller, larger, and more efficient. Comfortable indoor temperatures made year-round productivity possible in places that had once struggled through long, freezing winters. Heating had evolved from a single open flame into an invisible network hidden behind walls. Yet another revolution was already beginning. New fuels, cleaner technologies, and automatic controls would soon make staying warm easier than ever before, and completely transform the relationship between people and their homes. As the 20th century unfolded, heating entered a new era. Coal, once the fuel that powered cities and factories, slowly gave way to cleaner and more convenient alternatives. Natural gas spread through expanding pipeline networks, allowing millions of homes to receive a steady fuel supply without storing heavy loads of coal or chopping stacks of firewood. At the same time, electricity introduced entirely new ways to generate warmth, from resistance heaters to electric baseboards that could heat a room with the flip of a switch. Perhaps the greatest improvement wasn't simply producing heat, it was controlling it. The invention of the household thermostat changed how people interacted with their homes. Instead of constantly tending a fire or adjusting a stove, homeowners could select a desired temperature and allow the system to regulate itself automatically. Boilers and furnaces turned on only when needed, reducing fuel consumption while keeping homes consistently comfortable. For the first time in history, warmth became something people could expect, rather than constantly manage. By the middle of the 20th century, forced air furnaces became increasingly common, particularly in North America. A single furnace heated air before distributing it through ducts hidden inside walls and ceilings. Every room could receive warm air within minutes, creating a level of comfort unimaginable to previous generations. Modern insulation, double-glazed windows, and improved building materials made these systems even more efficient, trapping heat inside homes instead of allowing it to escape into the winter air. Then came another remarkable idea. What if heating didn't need to create heat at all? Instead of burning fuel, heat pumps move existing heat from one place to another. Even cold outdoor air contains thermal energy. Using refrigeration technology in reverse, modern heat pumps extract that energy and transfer it indoors. During summer, many of these same systems reverse the process, carrying heat out of the house to provide air conditioning. One machine can now both warm and cool a home while using far less energy than traditional heating systems. This technology has become increasingly important as countries work to reduce carbon emissions and improve energy efficiency. Engineers continue developing geothermal systems that draw stable temperatures from deep underground, solar-assisted heating that captures the sun's energy even during winter, and district heating networks that recycle waste heat from factories and power plants instead of allowing it to disappear into the atmosphere. Today, heating systems are becoming smarter than ever before. Digital thermostats learn daily routines, adjusting temperatures automatically before people wake up or return from work. Motion sensors detect whether rooms are occupied. Smartphone apps allow homeowners to control heating from anywhere in the world. Artificial intelligence is beginning to predict weather changes and optimize energy use without requiring any human input. What once demanded constant attention now works almost invisibly in the background. Yet despite all this technological progress, the fundamental purpose of heating has never changed. Whether it was a small campfire glowing outside a prehistoric cave, the warm stone floors of a Roman bathhouse, the crackling fireplace of a medieval cottage, the cast-iron stove of the Industrial Revolution, or the silent heat pump inside a modern home, every generation has faced the same challenge: surviving the cold. The story of heating is, in many ways, the story of civilization itself. It shaped where people settled, influenced the design of homes and cities, fueled technological breakthroughs, and made it possible for billions of people to live comfortably in climates that would once have been almost uninhabitable. Every winter, when a thermostat quietly clicks on or warm air flows through hidden vents, it's easy to forget the extraordinary journey behind that simple moment. But that comforting warmth is the result of hundreds of thousands of years of human curiosity, engineering, and determination, a journey that began with a single controlled flame and continues to evolve as humanity searches for cleaner, smarter, and more sustainable ways to stay warm.